Yes. Good afternoon, all. Myself, Kaushal Barot, Assistant Professor, Mechatronics Engineering Department, PIT. Webinar session on Internet of Things with PLC. I welcome Mr. Ankit, who is a branch manager and Ofcon India Private Limited. He has 7+ years of experience in the field of automation and training for engineering. He is providing vocational training, expert talk, industrial training. With this, I request Ankit sir to start the session.
Okay, thank you so much, sir. Am I audible, sir?
Yes, sir.
Okay, so very good afternoon to all of you. So today we have a session on, you can say, Internet of Things IoT with PLC. So as we all know that nowadays people are lots of talking about IoT, right? So today we have a session on that same topic, IoT with PLC. So I have chosen this topic, you can say IoT with PLC, because end of the day we all are graduates going to work in the industries, and nowadays you also know that there is a huge demand of automation technology. So there are big industries are using a PLC, programmable logic controller. So today we will do Internet of Things with PLC. So let's talk about the agenda of today's webinar. So first we will uh, discuss about what is PLC and basic programming. Then after we will go into that what is IoT, how it works, and applications of IoT. Then we will talk about the what is node RED, that I will explain you in detail in later. Okay, that is a one type of gateway which we are going to use for IoT purpose with our PLC. Then what is cloud, and then after we will do some practical exposure, like we will send and receive data between our controller, or you can say PLC and cloud. We will send few data from our PLC, our controller, to cloud, as well as we will receive commands from cloud to our PLC, and our process is going to run accordingly, right? So now first let's talk about the PLC. What is PLC? PLC stands for, you can say, programmable logic controller. It is an industrial controller, right? So if you talk about about the automation technology, so there are lots of type of automations are there. Industrial automation is there, home automation is there, office automation is there. So when we talk about the industrial automation, and if we want to do automation in our industries, then we have to use some industrial controllers to automate our process. So for that we are using PLC, programmable logic controller, which is, you can say, it is a solid state device, and PLC is a control hardware which programmable interface between field input devices and field output devices. It is going to interface between your input devices and output devices. You have to do some coding in your controller. Accordingly, that process is going to run when we will run it, right? So here you can say this is the image of PLC, programmable logic controller. Initially, this controller was invented in around, you can say, 1969, and that was firstly introduced for the automotive industries, that is General Motors. And nowadays all manufacturing industries, process industries, you can say pharmaceutical industries, food processing industries, they all are using this controller for their automatic process. Now the PLC, any controller has an architecture. So similar way, PLC has also architecture. So that PLC has input modules. Then that PLC will be having a CPU, central programming unit, right? And then after output module, and you can say power supply. So this will be a 4 modules over there in our PLC, right? So we will connect some input modules at inputs at our input modules. We will give a power supply to run our PLC. Then we will do a coding, and we will download that code, or you can say download that program in our CPU and RAM, right? The CPU is going to run that program, and that program is going to store in memory. And accordingly, whatever we have created a logic, or we have created a programming, accordingly our output module is going to run, right? Okay, so that is the simple architecture of PLC. Now there are different types of PLCs are available in market. That could be based on, like, there are, you can segregate or you can bifurcate it based on their size, based on their hardware setup, or based on their power supply also. So in based on size, it means number of input outputs. Any PLC has an input and output. As we discussed, there will be an input module, as well there will be an output module also. So PLC has some inputs and some outputs will be there. So it is going to be a ratio of 60-40. 60% will be input, 40% will be output. Suppose I have a 10 IO PLC. Number of IO is 10 in any PLC. It means what is going to happen? It means that PLC has a 6 input and that PLC has a 4 output, right? So that is based on size. So there will be a nano type PLC will be there, micro PLC will be there, medium PLC will be there, large size PLC will be there. Then you can segregate by the number of IOs. Now the main thing that we bifurcate it based on their hardware setup. That is, we will get a different types of PLC over there. You can say compact, modular, or hybrid. You will get it over there, and based on power supply, because as already we discussed in this earlier slide, that PLC has a power supply modules also. So in some PLCs we are getting a inbuilt power supply module, and in some we have to give it from the outside, like we have to use the SMPS over there, power supply module over there, right? So there will be a majorly 3 types will be there: compact type PLC, modular type PLC, hybrid PLC. Okay, so what is the compact means? Compact means that PLC having a fixed input output. Suppose it is having a 10 input output, so you can use only 10 input output. More than that, suppose if you want to connect, suppose 10 output is IO is there, it means 6 input and 4 output. So suppose if you want to connect a 7 number input over that, then you cannot use because it has a limitations. And in compact PLC, what is going to happen, as we discussed in architecture, that PLC has an input module, output module, power supply module, and CPU. So this is going to be a combined together, and it will look like this. So it will be a compact type. Then what will happen in modular PLC? In modular PLC, all these modules are going to be separate, individual. Power supply will be individual. Then you can say input module will be individual, output module will be individual. So if any module gets damaged, then you can replace it and your PLC is going to work. What will happen if in compact PLC, if anything is got damaged, then this is going to be completely best for you. So in modular, you can change your modules and your PLC is going to work. And what is the hybrid PLC? In hybrid PLC, it is going to work like, it is similar like a compact type PLC. This is hybrid, similar like compact PLC, in which all modules will be combined together, but you have some you can say you can extend some input output modules over that, but that will be a very limited. You cannot connect like a modular PLC. You have a limitations over there. So this is the type of PLC. Then any PLC has an output module. That has a 3 types of output module. One will be relay, second will be transistor, and the triac. So what is the relay? It will give you output in AC and DC both. In transistor, you will get only DC type output, and triac you will get only AC type output. So whatever application you have, whatever the output type you have in your devices, accordingly you have to choose your PLC. So if you talk about the selection criteria of PLC, then that depends on lots of parameters, that you can say like number of input outputs, then the PLC scan time, then protocols, which protocols you are going to use. You want to use serial communication, you want to use Modbus, Profinet, Profibus, Ethernet IP, DeviceNet, ControlNet. So these are the protocols. So depend on your application, you have to select your PLC. Now there will be, you people already know about the output input and output module type. There will be 2 type of modules. You can say analog or digital, discrete or analog. So this is the list of like in input. If you talk about the discrete type, so what will be our input? Push button is our input, switch is our input, limit switch, or you can say proximity sensor, photo sensor. So this is going over input as a discrete type. And if you talk about the discrete output, then relay, contactors, your lamps, alarms, routers, solenoid valves, any coils, that is going to be your output in discrete. And if you talk about the analog, then there will be you can say sensors, RTD, thermocouple, then flow sensor, level sensor, pressure sensor, gas type sensor. These all are going to be our input. And if you talk about output in analog, then our any actuators, our any position. Then after you can say control valve, which is going to you can control it by giving a feedback accordingly, right? So this is going to be your analog type of outputs. Now there are different type of brands are available for PLC. If you talk that Rockwell Automation, that is Allen Bradley is there, Siemens is there, Schneider is there, Mitsubishi, ABB, Delta, Honeywell, Yokogawa, Omron, and many more than 200 plus brands are there available for PLC. Now if you talk about PLC programming language, so I'm just taking a you can say like overview of this PLC, because our major topic is that IoT. So I will talk more about IoT. Okay. So there are different programming languages are there. That is ladder logic is there, structured text is there, instruction list is there, sequential function chart, SFC, that is in the form of flow chart, right? And function block diagram are there. And out of these 5 languages, majorly industries are using ladder logic, and then after FPD, function block diagram. So here you can see this is the one programming software that is called TIA Portal, Totally Integrated Automation. That is the Siemens brand software, in which I have connected various devices for communication purpose, or you can say for our entire process. Now, if you talk about the PLC programming, so this is the simple ladder logic programming over here. So if I talk about this logic, what is this logic? I have a suppose one push button, like I have a one application where I have a one start switch, or I have a one stop switch, and one motor I have there. So my requirement is that when I press the start switch, my motor is going to on. When I press the stop switch, then motor is going to off. So this is a very simple application that you can do with the hardware logic also. But if you talk about if you want to do in PLC, then with the ladder logic, then how ladder logic we can do it, right? So ladder logic, it means there will be a two ladder like this. This is phase and this is going to be neutral. From here, phase to neutral is going on. So in between that, you have to place your components and you have to create your logic. So if you talk about ladder logic, then we have to focus mainly on two things. One is like you can say NO/NC concept, NO and NC, and second is logic gates, and or not, whatever the gates are there, we should know about this. So what is NO? NO means normally open, NC means normally closed. So what will happen? NO means, like suppose if I have a NO type of push button, so what will happen? Initially it will be open. When I press that, so contact is going to be closed and phase will pass from here, and after that whatever we connect over there, our output is going to run. So NO symbol is like this, NC symbol is like this. Okay. So if I want to create a logic for this, then when I press the start switch, my motor should be on and output symbol will be like this. So what will be my logic? This is going to be my start switch and this is my output. Okay. So where from here phase is going on, from here there is one ladder, so neutral is getting over there, right? So initially it is open, so phase is not going to pass from there and our output is going to be on. When I press this button, so it is going to be converted into NC. So what will happen? Phase is going to pass from there, and what will happen? My output is going to on, right? So this is the simple logic of ladder logic. I'm not going inside deep, right? Let's go ahead and okay. So there will be a, you can see here I have given some addresses, percentage I0.0, I0.1, I0.2, Q0.0, right? So this is the address where I have a connected, like at a 0 number of input, I have a connected a stop push button. At a 1 number of input, I have a connected wire of my start push button, right? So this is the number where you have a connected your actual devices, or you have done the wiring accordingly, right? Accordingly, you have to give a addresses over here. So every brand has a logic will be same in every brand of PLC. Only the addressing pattern and some graphical representation of the software is going to be little bit changed. Now application of PLC, you can see who industry, like who can use this PLC, right? So you can say like all the industries are using, like already I said that manufacturing is like food processing or pharmaceutical, any chemical based industry, oil and gas industries, then you can say automotive industries, they all are using any packaging industries, and then after you can say cement and coal industries, they all are using programmable logic control PLC, right? You can see here petrochemical, oil and gas, steel, power plant, food manufacturing, automotive, cement industries, glass manufacturing, raw material handling, any industries. So they all are using PLC. Now, what is IoT? Our main topic is start from here. What is IoT? IoT full form is Internet of Things, right? The Internet of Things or IoT is essentially an ecosystem of physical devices. I will explain it, okay? Physical devices, vehicle, appliances, and other things that have the ability to connect and collect and exchange data over a wired and wireless network with little or no human to human or human to computer intervention, right? It is the simple. If we talk about in simple term, it is means IoT means taking all the things into the world and connecting them to the internet. Whatever the devices we have to connect with the internet so we can access it remotely from anywhere from the entire world, right? So this is the simple meanings of IoT, that whatever the devices we have to connect it with the internet, right? So now why people are talking lots of about IoT, right? So if you talk about the world population, it is approximate, you can say in 2020 it is around 7.6 billion. And if we talk about the connected devices with the internet into 2020, it is around 50 billion. So per person, you can say almost 6.58, or you can say consider 6 devices per person. 6 devices are connected to internet in a nowadays, and it is generating a huge amount of data, right? We will also talk about the some devices of IoT and application also in later part. So that's why lots of devices are connected with the internet. So that's why all people are talking about IoT nowadays. How IoT works? Suppose let's take an example how it is going to work. So there will be a, you can say lots of sensors will be there who is going to sense the data, who is going to sense the input, and then after we will give all those data to our gateway, and that gateway is going to give our data to clouds, and then after we can access those data remotely through our laptop, our desktop, you can say your mobile application, right? So this is the simple, you can say, working principle of IoT, that sensors or whatever the devices you have, that is going to generate a lots of data. That data is going to transfer to cloud using gateway. Gateway will be there. We have to transfer those data using that gateway, and then after it is going to go in our cloud, and then after from that cloud we will access it through our mobile, laptop, or any other applications or devices. Okay, so this is the simple. So major component, what are the major components of IoT? So that is sensors and whatever the devices you have. Then after the connectivity, right? Then after data is going to be processed, so it means data processing, and then after user interface. So what will happen in sensor devices? So whatever, like suppose you have a devices, like you can say in your mobile you have a GPS sensors, accelerometer sensors, then after ambient sensor, lots of sensors are available in your mobile. So it is going to sense based on their requirement or based on their working principle, and it is going to send data to our gateway, and then gateway will send data to those cloud. So sensors or devices, that is our input, who is going to generate the data, and it will send to gateways and cloud, right? Then after what will have connectivity? Connectivity, it means whatever the data is generated by those devices or sensors, that we have to send to the cloud. So we will use some mediums, or you can say protocols. We will send it through Bluetooth, we can send it through Wi-Fi, we can send it to cellular connectivities, right? We can send it. So there are lots of options are available, lots of protocols are available. Using that protocol, Zigbee is also available. So using that protocol, we will send those data to our cloud. So that is our connectivity part. Then what will happen? Data processing will be, so cloud will receive those data, and if you want to do some analytics over there, so analytics performance analytics will be applied over there, and based on that, that data is going to send to a user for their requirement, whatever their requirement. Based on that, they can take a decision, their business decision also, right? So that is our data processing. And then after user interface, so simple, we can say we will get those data in our mobile, in our application. From that we can monitor, or you can say we can control those devices, right? Suppose you can say you are wearing that smart watches. So that smart watches is taking all your activities, and that is going to send to a cloud, and then after from that cloud you are accessing all those information through your mobile application. So this is the simple example or simple application of IoT, right? Now what is the advantage of IoT? Suppose we have a 4 systems, and or you can say 4 processes going on. So suppose if it person is working over there, that person has to go everywhere, has to take care, and that person has to do a monitoring and controlling of that entire 4 systems, right? If you connect those whole system to a IoT with Internet of Things through with internet, then what can that this person can sit here and access all those systems, and he can do a monitoring and controlling from this system itself, right? So this is the biggest advantage of IoT, right? So now there are some disadvantages also in IoT. Okay, so there will be a security issues also there, privacy issue also will be there. Then after flexibility, complexity, and compliances, because this is still we are new to these technologies, and it is going to generate lots of data. We have to handle those data, we have to create our clouds, and we have to make our server compatible with that. And also we have to take care of security and privacy of each user, whatever the data is sent by. Nowadays, you know, all people know that lots of data are getting leaked from the servers. So these are going to be a little like disadvantages, but later on part people are working on that. It is also going to be resolved very soon, right? So if we talk about the challenges of IoT, IoT, then insufficient testing and updating. You can say concern regarding data security, as already I said, in a disadvantage. Then software complexity, it is not that much easy. Like it is not because we have to fetch the data, then we have to send those data to gateways. Then after we have to send it to cloud. Then from we have to do analysis. Then after we have to access data in our application or our devices, right? So data volume will be high. So we have to collect those data. We have to store that much of data also over there, right? As well, also you people know that how many data we are generating. Earlier we used to, you can say 4 to 5 years back, Geo was not there, so we used to like internet like 1 or 2 GB per month. But nowadays we are using a 2 GB or 3 GB, 5 GB per day. So based on that, you can consider how many data we are generating, right? So applications of IoT. So you can say, let's take example of smart home. You all people are aware about that, right? You can control your fans, your AC, your lights, also your curtains, everything from your mobile, right? Earlier we used to do it with the Bluetooth, but now we have connected with that internet, and from that our mobile application, if we are sitting at even in our office, but we can control that also, right? So that is the application of IoT. Then wearables, it means you are whatever the watches, or you can say like smartwatch or fitness belt you people are wearing. That is the example or application of IoT. Smart cities projects are going on, right? Then after automotive and transport industries, if you talk about Tesla, or if you talk about like recently MG, so you can open your sunroof directly by giving just a command, then open the sunroof. So over there, internet connectivity is already there. It is taking a command from you and it is giving command to that particular devices, right? So that is automotive and transport. Smart grids also are there. Medical, that is IoT is getting used more and more in hospitality, you can say medical and healthcare, right? Then after industries, nowadays what like manufacturing industries are also implementing IoT. Or you have heard the term that is industry 4.0. Industry 4.0, it means that is internet of things, IoT, and other technologies like artificial intelligence, machine learning. All these technologies, big data analytics are there, right? In agriculture also we are using a IoT, right? Maybe some people have created a project like that related to humidity, temperature of that soil and everything, right? So you are getting a data on your mobile, and if you want to start the water pump over, then you can give a command from your mobile. Earlier we used to do with the Bluetooth, but nowadays we are doing with internet, right? Smart supply chains or smart retail, smart supply chains, like recently you are using a Zomatos. So there you are in a lifetime, you are able to take the location of that rider, right? So that is what is that? That is internet of things. That rider access location is already like shared with cloud, and from that application is tracking, and through that application you are able to track the rider current location, or you can say live location. That is the example or application of IoT. So what are the IoT devices? You can say Google Home, Amazon Echo, Amazon Fire Stick, smart locks, or you can say Philips Hue bulb. Right nowadays smart bulbs are also coming, smart tube lights are also coming, right? That you can control from your mobile also. Smart watches, fitness belt, and the smart appliances, already you can say washing machines, and nowadays also are coming the smart, right? You will like control it from your mobile. You will get all the details on your mobile also. Now, as I said that then we have to send a data to cloud, right? So there are some platforms are available where we can store our data and we can use it, right? So that is available by, you can say, Cloud IoT Core by Google, Microsoft Azure is there, AWS IoT Core is there, IBM Watson, which is mostly used nowadays by people, and MindSphere, that is developed by Siemens. So these are the IoT platforms where we will store our data. You can say we will create a dashboard and we can monitor and control our entire process over there. Now, protocols, as I said, that we can use lots of protocol to send the data, right? So there are lots of protocols. Protocols will be divided into two parts: network protocols and data protocols, right? So network protocols, it will connect your gateway and cloud, and data protocol, it means it is going to transmit, send or receive your data from cloud to your device, or your device to cloud. Okay, so there are lots of protocols you available. I'm not going in deep of that, okay, because we have to perform practicals also. Now you can say, what is Node-RED? As I already said, what is Node-RED? So Node-RED is a flow-based development tool for visual programming developed by IBM for wiring together hardware devices APIs, it means application programming interface, and online services as a part of Internet of Things. So it is a simple, like as I said, na, gateway. We have to use a gateway to send the data to cloud. So Node-RED is going to work as our gateway from where whatever the data we are receiving, that through this gateway we are going to send to our particular cloud, and also we will receive a data, whatever the command is going to be, we are going to give from cloud, that command we will receive this on this our gateway, and this gateway will send it back to our devices. Okay, so this is, you can say, this is simple our like working as a gateway. So here you can see the simple images or programming, like this is a flow based programming where we have to use a ready-made blocks, and we have to connect each and every block with the wires based on our requirement. So that is flow based programming. Okay. Also, that Node-RED has a facility of dashboard where you can create this type of dashboard and visualization, so that you can monitor or control your entire process with with the help of this dashboard. Okay, so as already I said that what is Node-RED. Okay, now Node-RED is Node-RED you can work in many devices, like you can say you can run it and locally on your system, or you can say on your different devices, like if you have a Raspberry Pi, BeagleBone, Arduino, so you can use with that also, and also you can put it into cloud and you can do the programming over there, and you can you can create as a gateway, and you can send and receive data with the help of this Node-RED. Now, if you want to install a Node-RED in your system, then you have to install it with the help of a command prompt. So this is the simple command you have to install, like npm install pip, you can say perl Node-RED. So with the help of that, automatically it will fetch all the data from the cloud, and you will be able to install Node-RED on your system. Now, if you want to start a Node-RED, then how you can start a Node-RED? You just have to open your command, and you have to give a command, that this command node-red. So your Node-RED is going to start. Now, how Node-RED it looks, I will show you also. Okay, sometimes. Okay, who is using a Node-RED? You can say nowadays almost industries, almost software companies, you can say IBM, Microsoft, they all are using a Node-RED as a gateway in their platform. Okay. Now, what is cloud? Right? So the cloud refers to servers that are accessed over internet, and the software and database that run on the servers. Cloud servers are located in data center all over the world. If we talk about in simply, the cloud is the internet. Most specifically, it is all the things you can access remotely. If I give you a simple example of cloud, we are using a Gmail, right? Nowadays we are using a Gmail, we are using a Google Photo. What is that? That is our cloud, where our own emails or our photos are getting stored, and we can access it remotely from anywhere. We need a just internet at our devices, and we can access all those emails. It is not installed, or you can say it is not stored locally in our system. It is remotely. It is stored in data centers. You can say it is stored in cloud or server, from where we can access it remotely, right? So cloud simple example, if you are using Gmail, you can say Google Drive, or you can say Yahoo email. So those all are the simple example of your cloud, right? So now, what is cloud computing? And with this help of this cloud, we are going to store those data, and then also we can work as a, like we will use it as our system. We will do lots of analytics over there. So that is going to be our cloud computing. I'm not going details on that. Okay, so now let's take a practical example that is most important, that how all things happens in IoT, that I will show you. Okay, so as I already said that, first let me go into our PLC programming software, where I have created a simple, this is my PLC programming software. You can say this software name is totally integrated automation. Now, where what I have done, I have some data. Suppose I have one data, you can say, for that I have created one data block. In that I have stored this data with this name. Okay, don't go for the name, I just have created it randomly. Okay, so what I want to send data from this PLC to cloud, and I will monitor over there. And then after, what I will send data from my cloud remotely. I will send it anything from that, and that is going to receive by our PLC. So let me give you first you can say practical explanation. Okay, so this is, you can say, my Node-RED. Let me take it over here. So you can see this is my Node-RED application. So first what I have done, I have created some random data and stored in my PLC. So you can see there is a data 1 is there, data 2 is there, data 0 is there. Right now there is some values over there, you can see over here also. Right now what I have done, I have started my Node-RED, and then after I have created flow-based programming in my Node-RED. Here you can say I have created flow-based programming in my Node-RED. So just check it over here. The URL is like 127.0.0.1 slash. So this is my local Node-RED. So first what I will do, I will connect. I will just explain you. First what I will, this is my PLC. Okay. Then after I will connect first my PLC with my gateway. So that is my Node-RED, but that is local Node-RED. Okay. Then after what I will do, I will send it this data from this Node-RED gateway to my cloud. Okay. And on that cloud dashboard, I will monitor all those data. Okay. Now in second step, what I have done, I have a cloud. Okay. From there, I will receive a data on my gateway. That is my local Node-RED gateway. Okay, local Node-RED and remote Node-RED, that is on my cloud. Okay, and from that local Node-RED, I will get this data on my PLC. So this is the two things we are going to do. So first, I already created all those things. I will show you first. Okay, and this is a simple dashboard I have created. Right now, you can see in dashboard I'm getting a value of 30. Here you can say I have a data 0 which value is 45 and 20. So I will open my cloud. Okay, I will open my cloud, and here you can see data 1 value is 45. Similar, you can configure, you can monitor it. Data 1 value is 45, then data 2 value is 20, right? And whatever the data is used here, then after I'm getting the graph also, you can create like this also. Okay, device related information I'm getting, whatever the devices is connected, whatever the data is received from my local Node-RED to my cloud, that is also are listed over here. Let me change this value to, let me change this value. Okay, I'm changing this value from my PLC, right? That value is going to first in my gateway, and then after it is going to my cloud. So right now you can see now data 1 value is changed to 78. Here also you can confirm that is 78. And if it go into the, you can say here also that is my connect, that is my local, it is connected. Okay, now suppose I change value of this data to suppose 80. Okay, so you can see here I'm getting a value as a 80, right? Whatever that is. So how I created all these things, that I will explain you also. Okay, so this is the one thing what I have done. I have a sending data from my PLC to my cloud. Okay, now what I want to send a data from my cloud to my PLC, from my cloud to my PLC. So I suppose I have taken example, and I have a one data that is send underscore value. So I will send a data from my cloud, and it is going to update in my this PLC. So suppose I have created a one slider, you can say right now its value is 30. Let me change this value to 55, and here you can see send value is now 55. Let me change it again. Right now it's 25. Let me change it again. Right now it's 20, right? So both application we are going to, first we are going to send a data from PLC to cloud, and then second cloud to PLC. So what are the steps I have done over here that I will explain you. Okay, so first what we have done, I have opened, you have to open your Node-RED first. So I have opened my Node-RED on local system. Then after we have a various nodes are available in Node-RED, that is ready-made. So I have installed one Node-RED for my PLC, for my Siemens PLC, that is this one. You can see over here. Now what I have done, I have taken this node as here like that. Then after I have to configure all those things, like what will happen, it is going to receive a data from my PLC. Now I have done a communication with the Ethernet, or you can say Profinet. So as you all know that Ethernet is working on IP addresses. So it is going to receive a data from PLC, but how it is going to receive a data? So for that, what we have to do, we have to assign an IP over here. So I have to double click on this. I will go over there, and then after what I will do, I will assign. So my IP is this 127.0.1, and then after my port, I'm using that open port, that is 102. My slot number PLC has a slot, so it is slot number 1, and which data you want from there, that you have to assign in this variable. Okay, whatever the data you want. So suppose if you wanted data of this, you can say we want this data, right? So what you have to assign, you have to assign address of this. So how to assign? So address is going to be db1, that is my data block 1, and word number 0, and I will assign data 1 over here. Okay, and I will click on add. Okay, and I will select variable over here whatever we have created, and then after done. So that I have just done the configuration. Now what we have to do, we have to deploy it. Deploy it means we have to download it, right? We have to load it. Then after, what will happen, it is going to connect with my PLC. So when I click on this deploy, so you can say it is getting option that online, or you can say connected, and you are getting a value as a 78. As you know that we have a data 0 value is over here, it is 78, so we are getting a value as a 78. Right now, if you want to display those value on your dashboard like this, okay, if you want to display, then we have a lots of options are available for dashboard. From there you can take whatever you want. Suppose I want to display on gauge, so I will take a gauge, and you just have to connect like this. As I said, this is a flow based programming, so we have to just connect wires between two blocks, and then after you have to deploy it. Before deploying it, you have to assign a group, so then and then after it is going to display on your dashboard. Okay, and my suppose range is between 0 to 100. Okay, so then after I will deploy it, and you can see over here, now I'm getting a dashboard. So what happened over here, first I just got the data from my PLC to my local node. Now what I will do, I will send this data, send data of this data one to my cloud. So here I am using IBM Watson cloud, so I want to send this data to my IBM Watson cloud. Right now I just got it from my PLC on my local system. Now from my local system I want to send it to cloud. So for that we have a various node, already I said. So we have to use IBM Watson node. Okay, so for that what I have to do, I have to take this output node over here. Okay, and you have to configure it. Okay, so here what you can do, you have two options. You can register as a quick, or you can as a registered. Registered, it means it will be a secure. As I said that earlier said that there is an API through, right? So application programming interface, it means you have your security key. So if you have your security key, then you will be able to send those data to your cloud. Otherwise you will not be able to send it, right? Otherwise what will happen, if you do it openly, then anyone can access it, right? So for that what I have done, first you should have an account on your IBM Watson cloud. Okay, so first we have to create an account, and then we have to edit over here, devices, edit over here. You can say I have created one device, that's called a final name, which is going to receive all those data. So for that what I have done, you can see over here in my registered, there is a one organization name. What is the organization name? This is your organization name. Once you create an account in your IBM cloud, so you will get a unique name over there, that is going to be your organization name. So my organization name is here, so I have given my organization name. Then whatever the devices I have created, the device name I given over here. Then after what I have done, then after I have given the ID over here and my security key. This security key you cannot share with others, because otherwise the other people can also access your cloud, right? It is like your password. Okay, so I have given my security key over here, and then after I update it, and you just have to deploy it. So what will happen, whatever the data you are receiving through this node, now this data is going to store, or now that data is going to be on our cloud. So once you can see here also, when I go over here, we will see the different whatever the data. Right now you can see data 1 value is 78, data 2 is 80. Let me change it from the PLC now. Okay, I'm changing it from the PLC. You can see here, you can see now data 1 value is 71, data 2. So in real time it is going to update continuously. It is real time, it is going to update whenever we update in our PLC, it is going to update in our. So this local node This local node is our gateway. So first I have created my PLC data. Then after I downloaded the program into my PLC. Then after what I have done, I have created some programming in my local node, and whatever the data is received by this node, that I have sent it to this cloud. So this cloud is IBM Watson Cloud. Okay, so now I am receiving data over here. Then after what I have shown you, like I have given example of this, right? This is my dashboard. That's called a dashboard. IBM Watson Cloud dashboard, where you can monitor your process, where you can monitor your data. So right now you can see I have a values like this. Okay, so how you can create your own dashboard? So for that you have to go over here in board, and you have to create a new board like this, and you can give any name. Suppose I'm giving the name of Parul. Okay, then after, you don't have to do anything, just okay. Then after what you have to do, you have to go in your board, and you will have an option of new cards, where you can create a cards like that, whatever I have shown you earlier. So I will create, once I click on get new cards, I will get an option like you want to show your data in gauge and values, or in chart. Like suppose I want to show in gauge, so I will select a gauge. Then whatever the topic I have created to do communication, so that is final. I will click on that, and I will click on next. Then after, it is asking to connect it with the data set, which data you want to display over here. So I will click on this. Here I have to mention always event. So when I enter the event over here, so whatever data is received by cloud from the node RED, it is going, you will get as a list over here. Right now only we are getting a two data from there. So we got a two data. So suppose I want to display data two value. So I will select data 2, and I want to show in the form of number. So then I will press on next, and color you want to, whatever the color you want, you can select it. The name also you can, suppose I am giving like this. Okay, then after you to click on submit. So here you can able to say, right now its orientation is not proper, you can also change it. Again you have to go over there, and here you can say the setting size is there. You want small size, medium size, right, or extra small. Okay, suppose I want extra or normal size, it means small size. So I will select small, and you can see now we are getting. Let me change value from here. Suppose I'm changing. Okay, you can see in a real time we are getting. Okay, just okay, I will show you like this, so you will get a more idea. Just a minute. Okay, right, so this is like this. Let me change it from here. Suppose I am changing 73 value and updating it, and you can see in real time you get it over here 73, right? So initially what we have done, we have sent data from PLC to cloud over here. Now what I want to send data from my cloud to my PLC, right? So I am going to give data from this cloud. So I have installed my cloud, and this is my URL, right? This is my URL, and I have created this dashboard, right? So over here what we have to do, again we have to use some blocks over there, and we have to do a configuration, right? So for that what I have done, I have taken this block as an input, IBM IoT, because we are using IBM IoT, right? IBM cloud server. So I have taken IBM IoT over here. Then after, we have to do a configuration for that. So now for that what you have to do, whatever the application we have created in this cloud, right? So for that we have to generate our API key, as already said, that is very secure key, right? So that API key I have created. Okay, so using that API key, I have mentioned all this API details over here in that. And then after what I have done, it is going to send a data. Now it is going to send data, right? So first what I have done, I have taken one slider. You can see here I have taken one slider. So whenever I change the slider value, that is going to send to my PLC. So I have taken one slider from the dashboard, and then after, these things are going to our cloud. And the same thing what will happen. So now first you can see that from here we have sent data to our cloud, and now from that cloud to we want cloud. Now we want from that cloud to our Node-RED. So again, we have to go in local Node-RED, right? Because our PLC software in our local. So I have to go in local over here. Right now you can see this is my 127. That means my local, and you can see. And if you are getting this type of URL, that is my cloud-based server, right? So what I have done, this was sending a data to cloud. You can see over this one was sending the data to cloud. Now here, the same API keys and everything I have mentioned over here. Okay, so that is going to receive a data from my cloud. And then after what I have done, here we have taken an input. You can see here we have taken an input. So similar way we have a one box that is our output. So same what I have done, I have taken an output box over here. Same IP I have mentioned over there, and in variable where we want to store that value, that address I have to mention. So suppose in our PLC program, I want that value in this one, send value integer, and the number reference number is 6. So that's why, and the data block number is 4. So that's why I have a given address as DB4, and that is integer value, and the reference number is reference number is 6. So that I have given over here, and that also I display with the gauge. So you can connect a multiple blocks at a one side also. Here you can see from this one I have a connected a data is going to send to PLC. Then I also displayed it, and then also I have taken a gauge also over here. You can see it, right? Right now it's a 78. Now let me send a data from this PLC. So here you can say we have a send a data as 60. Now you can see here this is my local dashboard. So in local dashboard it is also saying that I received a 60. Now let's go in our PLC and check it. Our PLC controller also received a 60 as a data from our cloud, right? Another application I will show you, okay, which I have created. Let me enable this my coding which I already created, okay, and let me go into my cloud also. So you can see this is very complex things. You have to do lots of things with a similar in parallel, right? So that's why as earlier said, that system complexity is also there, right, in challenges of IoT, right? Okay, let me go into my cloud also, and let me disable this. Okay, I'm disabling this flow. It means it is not going to execute it now. I have created one, okay, and let me enable it and let me deploy it. Now if you see over here, this is the little bit difference, dashboard is different. Over here I have a one switch. So what will happen when I press this switch, my PLC input is going to on over there. So that is start switch, okay. You can see here right now its value is false. It means it is off, okay. So let me press this switch, and you can see right now it's true. I'm getting a out monitoring value as a true. When I off this switch off from my cloud, this is my cloud. You can see the URL is Baroda IoT, right? So this is my cloud, and you can see here in my PLC I'm getting. So what I'm doing, I'm sending the data from cloud to PLC, okay. So I'm getting a false over here, right? Now you can see I'm changing a value. So that value is going to store in this one, right? 40 over here in value one. I have a one tag. So whatever value I am going to change over here, that is going to store over here. You can see right now it's 35. You can see here this is my cloud address, and this is my local system on PLC. So I'm getting value as 35. Let me change it again. 55. I'm getting 55. Let me switch on again. I'm putting on switch. You can see I'm getting a switch as a true, right? So I'm sending. Now you will think like that, sir, you are working on one system and you are sending, maybe you have done some setting. So now I will show you on my mobile also, okay. Just let me show you on my mobile also. I will access my phone from my laptop, okay, and I will show you also. Just a minute. I'm connecting my phone. Wait for a few seconds. Okay, my phone is connected now. And here you can see the same thing I have right now. Okay, you can see. Now let me change it value. I'm changing a value from here. You can see in my mobile right now. I have opened the same link in my mobile and I'm changing value. You can see here the value is 60. And let's go in our PLC. Value is 60 or not. Okay, you can see here value is 60. Let me change it again. 15 and check it over here. Right now the value is 15, right? So this that I can console. Now if I'm suppose my process plant or my industry is in Baroda, but I'm sitting in Ahmedabad, or you can say I'm sitting in Delhi, and I want to monitor my process, then I can do it with the help of IoT. So that's why nowadays people are talking about IoTs, and that's why industries are moving to automation, and then after they are going to switch to the IoT. That is our industry 4.0. You can see I'm changing it. Also, let's give a command of switch off. So let's see in our PLC, my switch is off. You can see start switch is off. When I do it, when I on it, right? Again, you can see, right? So in a two ways, right now I have done the individual thing just to explain you that how we can send data from PLC to cloud and cloud to PLC. You can combine it together. For that, your code is going to be little bit of complex, but just I just want to clear all. I just want to clear it very. That's why I have created it separately. Otherwise, we can create in a single way also, that we will send it data. This is flow, right? So this call as a flow. So I will send it data from cloud to PLC as well as from PLC to cloud in a single flow also. Okay. For that, we have to do a coding accordingly. We have to connect our you can say gateway to our cloud accordingly, and we can do it at the same time also. Okay. So this is the simple things about IoT, Internet of Things, and how industries are using it, using these technologies. You can say Node-RED gateway and the IBM cloud, right? So that's it from my end. If you people have any query, you can ask me, so I will answer for that.
Hello.
Yes, sir.
I'm audible, sir, na?
Yes, yes, you are audible, sir.
Sir, yes, sir. Sir, there are actually many security challenges for the,
Yes,
like outdated hardware and software.
right, sir.
So, how much percentage it will affect, when people are using outdated hardware and software, then it will affect to the system performance at how much percentage point of view, sir?
Sir, it is not going to affect your system performance, but is it affect? It is going to affect on your security. If you are like your hardware is not compatible, then definitely you are not going to able to do all these things. Okay. Suppose you have an outdated. Suppose like today we have done IoT with the PLC. So if your PLC is not supported, you have outdated hardware, then you will not be able to process these things itself. So first you have to upgrade your hardware, and then after you can, as I earlier said, that still people are not using automations, but now people are switching to their industries on automations, and then after they can switch to this industry 4.0, or you can say IoT, right? So that's the recent situation. And definitely in IoT,
Sir,
there will be
second question will be related with, yes, sir.
yes, sir,
Sir,
continue.
second question will be, yes, sir. Second question will be related with data protection and security challenges. So, challenges, it is a kind of a major part when we are considering, when we are working with IoT and data protection.
Right,
So,
definitely that data challenges will be there, because as I already said that we have to store huge amount of data, and for that we require a dedicated server cloud for that, with a good, like you can say, with a proper security features over there, because nowadays also you are seeing that some of people, some of industries or some of companies website got hacked, because they are not using that type of cloud server over there. They are not doing like they are not taking an encryption subscription over there, and based on that easy anyone can hack their website easily. So similar thing is going to apply over here. We have to take, like we have to use a security plugins, or you can say security features. We have to take SSL encryption certification over there. Then it is, then there will be a, like you can say, less issue will be there. But definitely it is going to be there, and scientists or whoever are engaging in this technology, they are still working on it, and day by day they are like you can say, they are upgrading their technologies, upgrading their softwares related to security terms.
And regarding, sir, can we consider IoT have any kind of major social impact on the normal routine life? As a one of the question will be there.
So, sir, I'm not getting your voice, sir.
Hello.
No, sir, I'm not getting your voice, sir.
Yes, sir. Yes, sir.
Yes,
Hello.
yes,
Now,
yes,
now,
yes, audible, sir.
now, is it audible, sir?
Yes,
Hello.
yes, audible. Sir. Yes, audible, sir.
Yeah. So, sir,
Sir, it is getting
our
break.
routine life can be affected by using IoT.
So it is not like that it is going to affect, but like as I said that before implementing this technology, we are going to, you can say like we have to use automations, and due to that there will be a, like you can say already, as I said in my earlier webinar also, that if it implemented automation technologies and all these things, then definitely there will be a job, you can say job losses will be there, and that is going to affect society over there. And along with that, the privacy is going to be a major concern in these things, because all those data are getting stored in cloud, and if anything happens over there or anything like that, it's got leaked, then that is going to affect our society.
So, can we consider issue which will be there related with IoT also, sir?
Sorry, sir.
There is a term like IoT hacking. There can we consider that kind of
Sir, right now we are in
work with IoT,
right
sir?
now we are in digital era, sir.
Yes,
So
sir.
anything is possible, sir.
Okay. Yes, sir.
Because it's all, end of the day, everything is digital, and already it is created by us, so definitely it is possible, sir.
Okay, sir. Okay. And sir, regarding the data storage and that we are retrieving also, right? The data storage. So there is of that data storage error. That may be there, or we can say that it is 100% completely reliable system, sir. Data storage point of view.
So data, so like I'm not getting your point, sir.
Sir, data will be stored as, right? Hello.
Yes, sir.
So
Data
there
will
may
be
be, yes, sir. So there may be some percentage of error will be there when the data will be stored, or we can say that like there is no error and it can be work completely in terms of that, or that may be a 5% error or 2% error.
there will be sometimes, like if your algorithm is not going to work properly or anything happens, so sometimes it will happen. Suppose if I would say, like, suppose I'm giving you one example that let's take a home example. Suppose two persons are there in home and they are using a home automations, and if there is a issue related to any securities or any data mishaps over there, and if one person is giving a command and at the same another person is giving command and it is not going to work, so all these things happen, but by trial and run, and you can upgrade your system accordingly, and one day will come that everything is going to be a stable.
Okay, sir. So I think we have covered, sir, right? And from Parul Institute of Technology and Parul University, sir, I am very much thankful to you for the knowledge you have shared regarding PLC and how that you demonstration also, so that it will try to complete or cover that IoT with complete with that PLC reference. So that I am thankful to you, sir, for the knowledge sharing session. Thank you very much, sir, for
Thank you
such a
so much
nice session, sir.
for providing like this. Thank you so much, sir.